Big blocks are great for generating easy cubic inches, but we also know they can get heavy. So today on the Horsepower Monster, we're taking up the challenge to see if we can shove one of Ford's most famous big blocks into a smaller, lightweight Windsor package. 460 cubic inches, baby, and we're going to show you how we do it. Today, we're going back to the shops of Prestige Motorsports in Concord, North Carolina. The customer they're building an engine for originally wanted a Ford 460, but he was also a little concerned about the weight because it was going into a lightweight Fox body Mustang. So, the guys at Prestige put together a plan to give him that magic 460 number in a lightweight package that should be much more efficient than any of the old 385 series big blocks from Ford. The foundation of this build they went with is a 9.5-inch deck Dart SHP block. To bump up the displacement of a standard 350 by over 130% safely, you need both a ton of bore and stroke. Even with a standard 9.5-inch deck height and in iron, the Dart block weighs just 195 pounds and can handle a bore of up to 4.185 inches and a stroke of up to 4.25 inches. Prestige has already fully machined the block, and the bores have been bored and honed to 4/155. Dart says the minimum bore thickness is at least 230 thousandths of an inch, so that's still leaving them plenty of meat in the cylinder walls for a rebuild later on with lots of strength left over. And, as you can see, the crankshaft has already been set into place. It's a forged unit with a 4/250 stroke. That's less than the 4.36-inch stroke of the big block 460, but it's still an incredible 3/4 of an inch longer than a standard Windsor. Anytime you're stuffing a lot of stroke into a block, it's always a good idea to test fit the crank and at least one rod and piston combo to make sure that nothing hits when the rotating assembly spins over. Valve train timing will be controlled by a solid roller camshaft from Comp Cams. It's pretty big with 260 degrees of duration at 50 thousandths tappet lift for the intakes and 272 for the exhaust. There's a 110 degree lobe separation, and lobe lift will be 394 thousandths for the intakes and 367 for the exhaust. We definitely wanted a lot of strength on the rotating assembly to handle all the stroke and power Prestige expects to generate. So they went with a set of H-beam rods from LPC along with forged pistons from DSS Racing. The rods are a 4340 steel forging with a length of 6 inches 200 thousandths from center to center. The DSS pistons have an aggressive reverse dome to help keep the air and fuel mixture concentrated in the center of the combustion chamber to maximize burn speed. This is a lightweight slipper skirt design which should create minimal friction with the cylinder walls. The reverse dome is sized at 22 cc's, and it will also help keep the compression ratio down to a manageable 10.65 to 1, which can be tough with a really long stroke like this. If you look close, you'll notice 2 valve pockets on the right side. Prestige had to cut new intake pockets on these pistons to match up with the very cool cylinder heads we'll be using, but more on that later. To squeeze as much connecting rod length as we can into the engine, the wrist pin extends into the oil ring land. Now this is no big deal, but it does mean that we'll have to use a support rail, which is essentially just another thick ring, before installing the oil ring. To prep for the rod and piston installation, Cody McCleary, who specializes in the short block assembly, paints the crankshaft's rod journals with assembly lube, then does a final clean on all the cylinder bores and applies a thin coat of lightweight motor oil to protect the rings and piston skirts during initial fire up. Prestige will pre-lube the oiling system on the dyno, but since the cylinder bores are splash oiled, that won't help them here. McCleary finishes up the rod and piston assembly by installing the rings. This is a gas nitrided steel top ring set with a Napier second and 3mm oil rings. Prestige has gapped the rings to 20 thousandths for the top ring and 22 thousandths for the second. And now they're ready to go into the block. To get the proper stretch, the rod bolts are torqued to 75 pounds with Moly lube on the thread. Check out how close the rod's cap screw comes to the bottom of the cylinder bore. That's why it's critical to confirm all your clearances when building a stroker like this. Also, you can see that 4 1/4 inch stroke pulls the piston out of the bottom of the bore just about as far as it possibly can go. Now the engine moves over to Larry Broker's area to finish assembly. Whenever possible, Prestige uses an SFI certified damper from Innovators West, and this build is no exception. And once it's in place, he confirms that top dead center for the #1 cylinder is accurately marked by the timing pointer. The lifters are a set of tie bar solid rollers from BAM. Broker's already coated the lifter bores with assembly lube, so the lifters can now drop right into place. Next up, Broker lubricates the threads on the 1/2 inch head studs from ARP and rolls them into position. Earlier, I mentioned the cylinder heads, and now we're finally there. These are a set of Trickflow's twisted wedge heads. They're famous for making power on Fords because this cylinder head ditches the normal single angle wedge style design and cants the intake and exhaust valves on 2 different angles to help maximize flow through each port. For these Trickflow heads, the intake valve angle is 15 degrees, while the exhausts have been tipped over an extra 2 degrees for 17 degrees of total angle. To go along with this, these are Trickflow's race version with fully CNC cut combustion chambers and ports. The chambers are sized at 65 cc's, and they're outfitted with large 2-inch 80 thousandths intake valves and 1-inch 600 thousandths exhausts. With 460 cubic inches, we're going to be moving a lot of air, so the intake ports are sized pretty big at 225 cc's. The exhaust ports, meanwhile, are raised to help get the burnt remnants of combustion out, and they're sized at 100 cc's each. With the naked eye, it's difficult to see the difference in the valve angles, but if you look at the valve stem tips at the top of the head, it gets easy to see how the angles on the intakes and the exhausts are set differently. The intakes are leaned in towards the center of the engine so that the air and fuel flowing through the intake manifold and intake port has an easier path getting into the combustion chamber. Along with some very high quality CNC work, this works out to pretty impressive flow. At 500 thousandths inch valve lift, these heads are rated at 308 cubic feet per minute of air through the intake ports and 244 through the exhaust. And for high lift applications, the flow through the intake can be as high as 341 CFM at 700 valve lift. Prestige is also using the spring package that Trickflow spec'd out for the race version of these heads. These are a dual set of valve springs held in place with a set of lightweight titanium retainers and 10-degree locks. At 2 inches installed height, that's worth 235 pounds on the seat, and at around 650 thousandths lift, they're producing right at 540 pounds of pressure. It's also obvious that this head was designed around max effort engine builds because the spring setup can handle as much as 720 thousandths of an inch of valve lift. Anyhow, we've got a set of Felpro head gaskets sealing between the heads and the block, and Broker locks everything down by torquing the nuts on the head studs to 100 pounds each. Next up, Broker begins installing the valve train. For better valve control, Prestige is using a shaft mount rocker system from Jesel. The first thing that will go down are the rocker stands, which the rocker shafts mount to. These help provide a stable base for all the rockers because it's a beefy solid steel bar that's secured to the cylinder head pretty solidly with 8 fasteners. To connect the lifters to the rockers, which will soon be installed, Broker is using 16 chromoly one-piece push rods. These are 5/16 of an inch in diameter with an 80 thousandths wall thickness. And because of the 2 different valve angles used, don't expect to be able to get by with a single set of 16 push rods. The intakes are 8 inches 950 thousandths long, while the exhausts are 8 inches 900 thousandths. Jesel's rocker arms are lightweight aluminum units. They're a little bit higher ratio at 1.65 to 1, where the original Windsors are 1.6 to 1. This makes gross valve lift 650 thousandths for the intake valves and 606 thousandths for the exhaust. The bolts securing the rocker shafts to the stand are secured with 26 pounds of torque, and then Broker lashes the rockers to 14 thousandths cold. Once the engine is running on the dyno, they'll recheck with a hot lash target of 20 to 22 thousandths of an inch. To maximize power in a naturally aspirated engine, the ports have to be as efficient as possible. And to help ensure this, Prestige matches the intake runners to the ports by hand on almost all of their big power engines. The process Prestige uses to print the cylinder head's port shape onto the intake is pretty cool, so we thought we'd show you the steps. Broker begins by painting machinist dye around the intake runners. Now this is just basically to help create an easy to see contrast for the next steps. Next, a little adhesive on the backside of the intake gaskets will not only help ensure they won't slide around, but it will also help eliminate leaks later on. Broker lays the intake gasket in place. If necessary, it can be trimmed to fit the intake ports perfectly. Then the gaskets around each port are painted with Prussian blue. Sometimes it's also called high spot, but whatever you use, it should be a contrasting color to the red machinist dye, and it should be non-drying so it will transfer well from the intake gaskets to the manifold, as you'll see in a bit. So once all the ports are painted, Broker carefully drops the intake into place, making sure both intake gaskets stay in their correct position. Next, he bolts it down to get good consistent pressure between the intake and the cylinder heads. After that's done, he pulls it back off, making sure not to smear the dye. Here, you can see the results of printing the intake. The Holley tunnel rams runners are smaller than the big ports on the trick flow cylinder heads. The purple is where the blue from the cylinder head's intake gaskets printed the Prussian blue onto the red on the intake manifold. So the area that's still bright red, you know, is smaller than the intake ports on the cylinder head and can be safely ground away to get a perfect match. And that's exactly what happened as LJ McCleary roughs in the larger port shape onto the intake. Notice that he's already taken the time to mark the final shape onto the machinist die before getting started. That's because the Prussian blue doesn't dry and it can be smeared and rubbed off if you aren't careful. We didn't hang around for all the detail work, but after about 5 hours of grinding and sanding, here's the final product. You can see how far back into the runners McCleary worked. The dark area is the original runner shape. While McCleary has the intake in the grinding room, Broker continues work on the long block. Here you can see the Melling high volume oil pump with a pickup attached for a rear sump oil pan. And speaking of the oil pan, we'll be using a Canton road race pan with internal baffling, which helps maintain plenty of oil around the pickup no matter how hard the car is accelerating, braking, or turning. Broker makes a quick check to make sure the bottom of the oil pickup will be within 1/4 to 3/8 of an inch of the bottom of the pan so that the pickup never comes uncovered. Once that's confirmed, we're ready to drop on the gaskets, spread a little silicone insurance, and set the pan in place. With the oil pan bolted up, we can turn the engine back upright once again and return our attention to bolting up the port-matched Holley high ram intake. This time, Broker applies a bead of silicone to the china rails because this installation will be for real. And here's a look from the intake plenum into the intake runners, just so you can see how well they match up to the ports now. And this is important because we plan to be moving a ton of air and fuel to make power. So far, we've only shown you the bottom half of the high ram intake. Prestige plans to use a front breather plenum top, which bolts right up. But first, Broker installs the O-ring that provides the seal between these two sections. Before dropping on the plenum top, now is also a good time to install the Holley dual sync distributor. Holley's dual sync distributors are really helpful when adding EFI to an engine like this because they have two Hall effect sensors under the cap, which means they can track both the crankshaft and the cam position. Now the plenum top can go on and be bolted up. To deliver the fuel, we'll be using a set of 8 48 pounds per hour injectors. Here, broker installs them into the Holley billet fuel rails and bolts the assembly up to the intake manifold. Now we jump forward a little bit. Bolted up to the intake is a 105mm Holley EFI throttle body. Broker also bolted up a serpentine belt drive for March performance that will spin up an alternator, water pump, and power steering pump. Now at this point, we usually head to the dyno and start making pulls, but we've got a little bit of a curveball for you. Previously, Prestige had just built the 1,000 horsepower nitrous Ford that we documented in a video. And it's a good one, so if you haven't seen it, please check out the link in the description below. For that engine build, we also used a Holley high ram intake, but with 2 1000 CFM throttle bodies mounted right up top. Thankfully, that one was also sitting in the shop. Now, out of curiosity, we wanted to see how the 2 different style plenum tops compared. Because the customer ordered the front breather setup, and Prestige always wants to make the final pulls on the dyno with the engine in its completed form, we started with the dual throttle body setup so we could finish with the front breather and the 105mm throttle body at the end. So we fired up the 460, now sporting its twin 1000 CFM throttle body setup. You'll notice there's a nitrous solenoid still bolted on, but there's no nitrous plumbed up, so it's not doing anything. The engine pulled strong from the beginning of the run all the way to the end. The 460 broke 500 foot-pounds of torque by 4,100 RPM, and it didn't drop back below that mark by the time we stopped it at 6,700. Peak torque was 571.4 foot-pounds at 5,400 RPM, and we had peak horsepower numbers of 642.7 at 6,500. This configuration places the 2 throttle bodies directly over the runners, so we thought this would likely be the strongest of the 2 combinations. After pulling the twin quad's plenum top, we bolted up the front breather with its 105mm throttle body and prepared for a second blast. It didn't take long for the Terminator X ECU to learn the parameters of the new intake setup, and we were ready to go. Everything else, meanwhile, stays exactly the same. Although both were really strong, to my mild surprise, the front breather setup with a single throttle body actually did better throughout the RPM range than the dual quad setup. The torque line was nearly 20 better throughout, and this time it hit an amazing peak of 590.5 at 5,200 RPM. Horsepower, meanwhile, was also better throughout the pull, and it broke the 650 mark with 668.2 horsepower at 6,900 RPM. Frankly, these are outstanding results for any naturally aspirated small block burning pump gas. The old saw that there's no replacement for displacement still holds true, and being able to get an amazing 460 cubic inches out of a 350 Windsor block definitely pays dividends. Plus, being able to make more power out of the front breather setup is also a bonus. This orientation is just better for packaging. It keeps the air inlet low and the filter out in front of the engine instead of up on top of it, so it's easier to fit this engine into low-slung sports cars without having to chop holes in the hood. The original 385 series Ford 460 engine was never rated for more than 245 horsepower and 400 foot-pounds of torque. And during the smog era, it actually dropped as low as 197 horsepower. Now, thanks to great part selection and modern engine controls, this 460 keeps the coveted 460 cubic inch displacement, is both lighter and smaller than any 385 series Ford 460, and it churns out an astounding 668.2 horsepower. That is more than enough to make any Mustang feel like $1,000,000. If you haven't already, please like this video and leave a comment about what you'd like to put this engine in. Hey, thanks for watching, and we'll see you next time.